Hello and welcome to the third module of session 4. We continue our discussion on the single period inventory model. Now, in the last module, which was module 2, what we had done was we had considered the analytical method of solving the single period inventory model problem. Which means that we use the critical ratio computed from the unit shortage and the unit excess costs and used the normal Z table to get our optimum order quantity Q star. So that was fine, it was a fairly simple method which we used to find our optimal order quantity. Now, one question which remained to be answered at the end of the last module was that, fine, we have got Q star, but what about the optimum profit itself? We have not calculated what is the profit at Q star. So today's module, this module number 3, we are going to discuss a method for calculating the expected profit for Q star, and as we know, this expected profit is going to be the maximum expected profit. Good? So let us start. Okay, so here we are. Now, this particular discussion involves a little bit of, quantitative stuff, just as, we had in the previous modules of this session. But don't get too bothered about it. As long as you pay attention and understand, what we are talking about, it should be fairly simple. So let us start by looking at the profit function, okay, which is called profit as a function of order quantity Q. Okay, so therefore we are calling it PR. Within brackets we have Q. Now this profit has got two possible values, okay. The first one, when the order quantity exceeds the demand, which means the demand is less than the order quantity, how much are we able to sell? We are able to sell the minimum of demand or order quantity, and in this case the demand is less and therefore we sell whatever is the demand. And therefore what is the revenue that we generate out of that? The revenue is P, the unit price, selling price, multiplied by the sales volume, which is the demand. So Px is the revenue in this case. Good. Now, you might see here that we have included a term called G into Q minus X, and this term has a positive sign, which means that it is contributing to the revenue or the profit, and rightly so. Now, let us understand this. Because the demand is less than the order quantity, we have gone excess. We have gone excess over the demand. And therefore, the quantity by which we have gone excess is obviously Q minus X. And this quantity Q minus X, which is the excess quantity left with us, can be salvaged at a value equal to G, and this G multiplied by that quantity Q minus X is the inflow of money into the kitty, and therefore gets added to the overall revenue, which is P times X. Okay, fairly simple. And then of course, because we are talking of profit, the first two terms give us the revenue minus C times Q is the total cost in this case. And this net, gives us the profit at any quantity Q, as long as Q is greater than X. Fine. Similarly, if you look at the second function, this is the case where we have gone short, which means Q is less than X or the demand. How much are we able to sell? We are able to sell only quantity Q. How much are we able to earn as revenue from that? Well, P times Q is the revenue that we earn. Okay. Now, here we have included capital B, and if you remember from the module 2, B was the additional penalty for falling short. Okay. And by how much have we fallen short? We have fallen short by the quantity X minus Q. And therefore the penalty, the total penalty cost is B times X minus Q with a negative sign, because penalty is something that we have to pay. It's a cost for us. And then of course we have the purchase cost or the production cost, which is C times capital Q. Now C times capital Q is common to both, because that is the total cost we incur in any case. Okay. Good. So therefore we have got two possible profit function. Please note that at a particular Q, if I fix Q, the only variable in this function is X, which is the demand, and we know the distribution of the demand, assuming that the demand is normally distributed with a certain mean and a certain sigma. We can actually go ahead and calculate the expected profit for a quantity Q. Okay? The expected or the mean profit for a certain quantity Q. Now this expected profit, let me point out here, you remember our numerical method where we use the Excel for calculating our profit figures for various values of demand for a particular Q? And then at the bottom, we took the sum product of these profit values and the probabilities to get the expected profit for that particular Q. Now, this is what we are talking about in a more analytical framework. Okay, so this is the equation or the formula that you can derive. Of course, derivation of this formula is not within the scope of this course, and it is really not required. As long as we are able to understand what this formula is telling us, we should be done. Okay, so let us look at this formula. It says expected profit at a quantity Q is equal to term 1 minus term 2 minus term 3. Okay, so we have got three terms there. Let us spend some time in understanding each of these terms. Okay, now this term, this value, expected sale, okay, so expected sale is the average units sold by us, and how much is the profit that we earn on the average sale? Well, the selling price minus the unit cost price, this is the contribution per unit multiplied by the expected number of units sold. Okay, so this is the total profit contribution from sales. Okay, so fairly simple to understand. Now let us come to the second term, expected inventory. Now expected inventory is the inventory which is left over. Okay, this is only an average value of that leftover inventory at the end of the demand season. So what do we do with that inventory? We salvage it at a value G. And therefore, how much money do we lose per unit that we salvage? Remember, we had spent C dollar in buying one unit. We get G dollar by selling one unit, and therefore the net cost for us is C minus G. Okay? So C minus G is the unit net cost over the for the excess inventory, and that multiplied with the expected value of the excess inventory is going to give us the cost that we incur in that excess inventory. Let us come to the third term. Now there is something called expected units short. Now here is a case where the demand exceeds whatever we have ordered, and whenever that happens, we are short. And whenever we are short, we pay a penalty equal to B, capital B. And therefore, this cost is capital B, which is the penalty per unit, multiplied by the expected number of units that we are short, okay, gives us the total cost of being short. So this is our equation for expected profit. Now there's something which might seem a little puzzling at this stage to you, which is that, you know, at the same time we are talking of inventory leftover, and we are also talking about expected units short. Now at the same time, how can we have both inventory leftover and expected units short? Well, you know, the expected units short is only a calculation of units short under various demand scenarios multiplied with the probability. So it is not that every time we are short. We may be short only a few times, you know, only at those times when the demand exceeds the quantity that we have ordered. Not for all demand values. But when we do a calculation of the sum product between unit short and the probability, we will obviously we are all going to get some value for expected unit short. But at the same time, for the same set of demand and the order quantity, there are going to be occasions when the order quantity is going to exceed the demand. So there are two possibilities. There are cases when the order quantity is going to be less than the demand, for which we have the last term, expected unit short, and then there are occasions when the order quantity is going to be more than the demand, for which we have the second term. So I hope that clarifies that, yes, at the same time, we can have both expected inventory leftover and expected units short. Good. So far, we have been able to navigate through this formula or equation. The only question you might ask is, you know, what is this expected sale or expected inventory or expected unit short? So for that, let us understand this. Expected sale, which means whatever we are able to sell, is equal to the expected demand, okay? Whatever is the demand, we may be able to sell that, minus the expected units short. Now, why are we saying this? You know, we are saying this because this expected sale is going to be exactly equal to the demand or the expected demand whenever expected unit short is 0. And when is that going to happen? That is going to happen when my order quantity is going to be more than the demand. So whenever the order quantity is more than the demand, my expected sale is going to be exactly the expected demand, the mean value of demand. But then there are going to be times when the order quantity is less than the demand, and whenever the order quantity is less than the demand, then we are only able to sell the order quantity and not the demand. So when you combine both these cases, you get expected sale equal to expected demand minus the average number of units by which we go short. Okay, so I hope conceptually you are able to understand why we are saying this. Okay, now what is expected inventory leftover? This is also fairly simple to understand. How much do we have to start with? How much inventory do we have before the demand period begins? We have ordered for Q units, and therefore we start with Q units. Now, how much of those Q units are sold away? That is expected sale. So how much inventory should we be left with at the end of the sale? Well, Q minus expected units sold. Now, expected units sold is this. We have already done that. So therefore, my expected inventory is Q minus this value. Okay, so in this equation we have, so let us stick expected sale because expected sale is this. Let us stick expected inventory because expected inventory is this. Now please note that expected sale and expected inventory have got two mean values which we have to find: the expected demand and the expected units short. Expected demand is no brainer because that is already given to us in a normal distribution. In our NFL jersey case, for example, you might remember that the average demand was 32,000 units. Okay, so that is our expected demand. So expected demand is already given to us. The only thing we have to calculate or determine or estimate is the expected unit short, because expected unit short occurs here, expected unit short occurs in expected sale, and expected unit short also occurs finally directly in the profit equation. So therefore, we need to find out the expected units short. So here we are. Let us look at this equation. Okay, when do we go short? We go short only when demand exceeds Q, not when the demand is less than Q. We go short for a certain range of demand. What is that range of demand? The range of demand when we go short is Q to infinity. You know, demand starting from Q to infinity. That is the range of demand which exceeds our value Q, the order quantity Q, and therefore we go short. So therefore this is the integral Q to infinity. Okay, how much do we go short by each time? Well, it is demand minus whatever we have in hand, which is our order quantity, and that is X minus Q. So this is nothing but integral X minus Q, which is the number of units we go short by, multiplied by the probability for that X minus Q. And that probability, because we are dealing with continuous probability distribution, we use the probability density function, which is Fx dx. Okay, so this is nothing but number of units short multiplied by the probability of so many units being short, okay, for the entire range of demand values starting from Q to infinity. Now, once again, we are not going to get into the derivation of the result, final result, except that we are going to use the final result, and the final result comes out to be sigma D. Sigma D is the standard deviation of the demand multiplied by a function GZ. G as a function of z. And z is the same z which we have seen earlier. This is our standard normal variate. Okay? Now, what is gz? Gz is called the unit normal loss function. There is a formula which you can use to calculate gz, but you know, because it's a standard function, it is a function of z, you know, therefore we have tables just like the normal probability tables. We also have the tables for the unit normal loss function, and the tables tell us, they give you one column which are z which gives the values of z, and the next column which give you the g of z, and therefore if you have the value of z, you can find out the value of gz by just consulting the table. Okay, so what we are saying is that this is nothing but sigma d times gz. Sigma d is already given to us, and gz is something that we can find out from the table for the loss function. Okay, however, we need the value of z, but then the z value is nothing but q star minus mu upon sigma. This is how we you know, standardize any variable into a standard normal variable. You know, so the z value is q star minus mu d upon sigma d. Now, why are we using q star here and not any q? The reason we are using q star is because we are not interested in calculating the profit for any q. We are interested in calculating the profit at q equal to q star, because that profit is the maximum that we can get. If I have been able to confuse you so far, let me assure you that it is not really that difficult. Okay, so let us try and follow, you know, let us try and find out the expected profit in our NFL example with the data that we already are familiar with. And that data tells us that the unit cost for a jersey is 10.9, the unit price, selling price, 24, demand normally distributed, mean 32,000, standard deviation 11,000. Okay, now for this set of data, and remember we are talking of a case when there is no salvage, we are not considering any salvage value. We have already done this problem analytically to find out q star, if you remember in the last module, and we found that the q star was 33,210 units. So what is the z value corresponding to this q star? Well, the z value, like we said, is equal to q star minus mean demand divided by standard deviation of the demand. Okay, 33,210 minus the mean 32,000 divided by the standard deviation 11,000, and that gives us a z value of 0.11. You know, now this z value also corresponds to the critical ratio for this particular problem. You remember we found out the critical ratio, and from critical ratio we found out the z value. Okay, so this is the same z value whether you calculate it back from q star or whether you calculate it from critical ratio, it is the same thing. But for our case, in this example, when there is no salvage, z comes out to be 0.11. Okay, so far good. Now, here we are. I told you that, you know, it is very simple. Once you know the z value, from the table of standard loss function, the unit loss function, we can find out the gz, or the unit loss value corresponding to that z. Now what I have in front on the screen is a table which gives us, please note that the k written here is actually the z, okay, and this is the cumulative probability which we get from the normal table, and the third column gives us the GZ values. Okay, we are looking at a Z value of 0.11. So where is 0.11? Oh, here we have 0.11 Z value. The corresponding GZ value, if you can see, is 0.3464. Okay, so here we are for Z 0.11, GZ is 0.3464. What does that GZ does for us? Well, the expected unit short is equal to sigma multiplied by this GZ. The sigma of the demand is 11,000 multiplied by 0.3464. That gives us 3,810 units short. Now, 3,810 units is the expected number of units which we will go short with. Okay. Now, we have everything available to us to go ahead and use our expected profit formula. Now, before doing that, you know, expected unit short is 3810. We just saw that. Expected sale. Now, we will be needing the expected sale value in the first term of the profit formula. So expected sale is nothing but the expected demand minus the expected unit short. Expected demand is 32,000 given. Unit short 3810 we have already calculated, and therefore 28190 jerseys is the expected number of jerseys that we will sell. Okay. What is the expected inventory that we are left with? Well, we ordered for 33,210. Remember, our Q star value was 33,210. Okay, we ordered these many units. On an average, how many did we sell? Well, on an average, we sold 28,190. And therefore, on an average, how many are we left with at the end of the demand? So we are left with, on an average, 5,020 jerseys. That is the expected inventory on hand at the end of the demand period. And what do we do with this inventory? Well, we try to salvage it if there is a salvage value. However, please note that we are considering a case where the salvage value is 0. And also remember, we are not considering any penalty for going short in this particular case. Good. So now we have everything with us. Expected profit, we have already seen, is the contribution per unit that we sell, which is P minus C, multiplied by the expected sale, number of units sold, minus C minus G is the effective cost for the inventory, whatever is left with us after the demand has happened, multiplied by the expected value of that inventory, minus the penalty, per unit penalty cost, multiplied by the average number of units that we go short by. Okay? So, 24 minus 10.9, P minus C, multiplied by 28190. 28190 was our expected sale, minus C minus G. So this is 10.9 minus 0. Please note that G is 0 in our case, multiplied by expected inventory, which is 5020, minus 0 because B, the penalty is 0, multiplied by expected unit short, which is 3810. We need not have written this since this is going to be 0 in any case, and that gives us a value of $314,571. Now this value of the profit is the maximum expected profit that we can earn from the demand that we are given. So I hope this was fairly simple to understand. Okay, what do we do next? Let us repeat the same exercise now with a salvage value given to us. And if you remember, we were given a salvage value in the second part of this problem, and that was $7 per unit. This only means that any leftover unit, we are not scrapping it completely. We may be able to sell it off to somebody, whoever, at a much, much less price than the selling price. And in this case, that price is $7 per unit. Everything else remains the same. Now, what has changed because of this? Well, the first thing that changes because of the salvage value is our critical ratio. And from the critical ratio, our Q star changes. This time the Q star has gone up, as compared to the previous value. And because our critical ratio has changed, our Z value has changed. It is now 0.74. Okay, very easy to calculate that. And from the Z value and the unit normal loss function table, we find that the G value corresponding to 0.74 value of Z is 0.133. Simple. We have got the GZ. All we have to do is multiply this value of GZ with the standard deviation of the demand, which is 11,000 in our case, to get the expected units short. So there you are. We have expected unit short is equal to 11,000 multiplied by the GZ value, which is 0.133. And this time we find that expected unit short is 1,463 jerseys. Expected sale, well, that is expected demand minus expected unit short. So 30,537 jerseys. What is the expected inventory on hand? It is the whatever we start with, the Q star, minus the expected sale. So we started with a Q star value of 40,140. Remember, this is the order quantity. That means we received this many jerseys. How many did we sell? We sold on an average this many jerseys. And therefore, what are we left with? 9,603. Okay. So again, very, very simple. We put our values. Now remember, instead of 0, we have a 7 here and the corresponding values of the expected sale, inventory and unit short. And then finally, we get our expected profit as $362,583. So, like I said, it is not really that difficult, fairly simple. Now, what might make sense at this moment for us to do is to look at the comparison between the two parts of the problem. One where there was no salvage value, and the second one where we had a salvage value. So with salvage and without salvage. Okay? Without salvage value, so we have Q star values, expected unit short, expected demand, expected sale, expected inventory, and expected profit. Now, Q star value is going to be much higher for the case with salvage. Why is that so? And the reason, let me explain this. The Q star value directly comes from where? It comes from my critical ratio. Okay? Now, what is the critical ratio? The critical ratio is equal to CS upon CS plus CE. Right? Now, which of the costs, the CS or CE, is getting impacted by the salvage value? Now, when do we salvage? When we go excess. Okay? So the excess cost here, which is as the denominator, in one case, the excess cost is only C, when there is zero salvage. In the second case, when there is salvage, the C excess is C minus G. How much are we able to recover from one unit? We are able to recover G. But how much have we spent on that unit? We have spent C. And therefore, effectively, how much is our cost? Our effective cost is C minus G. Whereas in this case, the effective cost is C. Now, obviously, C is greater than C minus G. And therefore, the excess cost here is going to be much greater than the excess cost in this case. And therefore, the critical ratio for this is going to be much smaller. So the critical ratio for without salvage is going to be less than the critical ratio for with salvage. I hope that is clear. Okay. Now, if the critical ratio for salvage, with salvage case, is greater, that means what? What is the critical ratio? The critical ratio, if I may just recap, the critical ratio is the area under the normal curve. A bigger critical ratio is only going to give me a bigger value of Z. And therefore, what is my Q star? My Q star is equal to the mean demand plus Z times the sigma D. Now, this Z value is going to be bigger for C minus G as compared to for C. And because the Z value is bigger, my Q star value, what is Q star? My Q star corresponds to this, So the Q star value is going to be bigger. So this is something conceptually we need to understand. Okay. Now let us come to expected unit short. In the expected unit short, we find that, we have a much less expected units short as compared to without salvage. Okay. Now, why is that happening? Now, the reason why that is happening is because let us look at the order quantity. When you order more, here the order quantity is much greater, you end up selling more. Okay, does it make sense? Look at the expected sale. The expected sale here is much greater than the expected sale here. So when the order quantity is higher, you end up selling more. It's like saying, oh, how much do I lose? If I order more, what is my risk? My risk is that I may be left with inventory, excess inventory. Oh, and what is going to happen? If there is no salvage, then I'm going to lose the entire money. But if there is salvage, I'm able to recover something. And because I'm able to recover something from my excess inventory, I might go a little, more excess. And therefore, my order quantity increases, my sale increases, and my unit, shortage goes down because I'm able to sell more. Okay. So however, please note that the expected demand is the same in both the cases. Obviously, the demand is not going to get impacted by whether there is salvage or not. And ultimately, all of these result in a much higher value of expected profit for the case where there is salvage than for the one where we don't have any salvage. Okay, so I thought that it might make sense for us to look at the comparison between the two cases just to understand how the numbers are behaving. Good. I hope you had a reasonably interesting time understanding this module. So this brings us to the end of this session altogether. which was on the single period inventory models.